Welcome. Thanks for joining us today. This is Nick Bubich with Veriphase. In the last video we took a quick look at the single weld module. Today we'll expand upon that and look at the multi-weld module, which is probably my favorite tool within the ADT Pro workflow suite. It's really the first tool that allows you to plan your analysis process, do things like estimate the time it takes to complete a large job as far as the analysis part of it. Typically after collecting a bunch of phased array data files, there's really no easy way to predict how long it'll take to finish analyzing them, and often you don't want ADT to be the bottleneck and somebody wants to know, you got 20 files, you got 30 files, you have 100 files, how long before they can move that component, get back in that area and work, or whatever else they need to do. When you look at all those different files, there's really no way to really know how long it's going to take you to analyze them unless you notice something while you were scanning, maybe the number of indications, but a lot of times you can't watch the instrument that closely, or it's compressed data. There could be a lot of indications to review based on your code or procedure. Could be lots of flaws to size. There could be spatial relationships between the flaws that you need to work out. Could be some quality issues that you'd have to go back and rescan in order to be code or procedure compliant. Things like data dropout, loss of coupling. So really, again, you just have to open all those files, and it's really hard to tell. The other thing is data fatigue. If you have 100 welds you need to go through, could start out fairly indication free, but by the end you start reaching a bunch of indications, flaws to review, and you might not be the most fresh at analyzing data. Your eyes are starting to sting, etc. So today what we've done is we've accumulated 50 tube welds from an actual ADT client, which makes up about 0.4 gigabytes worth of data. Pretty small files, about 2.5, 3-inch diameter. I don't recall 100%. But we're going to go through those. It's going to take a little bit of time to load that many files, but not too long. But this is really a unique part of the ADT environment, and then it brings something new to the table, so I'll try to hit on that as we go. So I already have ADT open here. Again, we've went through the scan check module up to this point, which is really the quality auditor. If you're just really concerned about are my data files any good, and then the single weld when you really just want to process a single weld. We've kind of skipped over any of the reporting or viewing data via these modules, which we'll cover and kind of circle back to how they tie into these other ones. We're going to go into the multi-weld. You can see there's two main parts of the multi-weld selection tool. We can just add a single weld, so if we had the same weld but multiple files we had collected on it, we could use that, but we actually have, even though they're pretty much the same type of weld over and over and over, these are actually separate tubes. So we're going to go into the add multiple weld and treat each one of those welds separately so that we get a forecast for each weld and then kind of collectively. So here's our 50 tube welds. Again, this is actual field data that we received after the project. Let's go ahead and open all those. You can see the first analysis setup page is pretty much like the single weld. I just asked you to select single-sided or dual-sided, whether you want to analyze all the groups or a single group, but the rest is really output. Again, we're going to skip over the report and data viewer, some of the reporting or how we view the data, and whether or not we want to adjust for that additional gain if there is any. We just usually leave that automatically checked. So we're going to add that to the list, and you'll see it takes a little bit of time, but it's fairly quick. It's going to add each one of those, do some consistency checks as it goes. If we had selected dual-sided, but I had two 90s in the file, common errors that can happen in the field, we actually have a bunch of consistency checks up front to make sure the data is accurate as well, and it will alarm on one of those, and probably won't happen during this process, but those checks and balances are in there. That's why we have you select some of those things as we go. Okay, so we have our 50 welds inside of here, and I think I've said it before on scan check batch. This is very similar. There's no real hard limit as far as what ADT can do. You'll see the speed on these 50 welds, and you can kind of extrapolate, but it's really your computer programming, memory, RAM, things like that, that limits it. It's not the ADT program. But it really doesn't take a supercomputer to do it either. We'll just hit Start Priority MultiWeld, and the unique difference between single weld and multi-weld is we actually have a secondary menu. And this allows you to take the enormous amount of data we're going to give you about these files and kind of organize it in a way. So you're going to get all this information no matter what. It's just a matter of what your priority is, how you want to look at it. We can see here things like the total number of hits or indications that ADT finds, and then we have some code specific like ASME, 80% amplitude, 250 length, another one related more to the AWS criteria. If you're more concerned first and foremost about data quality, and then how to list those. But again, it doesn't really matter. You're going to see all that information. I usually just leave it on the total hits, and you can glean the information from there, especially on a 50 file run. If you do have your own criteria you kind of want to add into it, maybe 80 and 50 and 250 aren't really what you're concerned with, we could turn this on, enter a length and amplitude. We'll leave it pretty simple. We're just going to auto open the Excel report. This one takes a little bit of time as well, but it adds in very quick. You can see in the menu there, as it completes each one, it's going to be showing us that it's completed and moving on to the next one. This will take just a little bit, so we'll try to fill that time. One of the important things to understand, it's not only going to give us a report, but it's also making a digital file copy of the data to keep be code compliant, make sure that we don't ever touch that raw data. So that second or two that it takes to say completed is really remarkable in the fact that it's making a complete copy of an 8 megabyte file in this case, and it's also compiling the processing or reporting results into the final report. There's a lot of options we could do. We're just going to get a analysis planning report, which is really the core difference between multi-weld. But really, when you run multi-weld, you can have it create the copy of the file, so you can analyze each file when you're done, or the ones that need it. You could have individual reports that we haven't touched on yet, compiled pre-analysis, and you could also have the data viewer, which is kind of our novel file type that we'll save for the next video. All that could be happening as you see it saying analyzing completed, but for the multi-view we're going to focus on the multi-view multi-weld specific feature of just the analysis planning report. Looks like we got about 20 seconds left. Total time has been about a minute and a half almost. I'll just give it that last 10-15 seconds and it should pop open the analysis planning report, and we'll take a deeper look at both the data created and the report. Just finishing up there. Asks us where we want to save it. We'll save it into that tube inspection job where our data was. Gives it a name. You could rename it there if you wanted to. So before I go into the report, there you see the elapsed time. So we did 50 files. It took about 2 minutes 6 seconds, so pretty quick. So let's first look at the data. So this was our original data. We have to move it over to here. So here we have the report. We have all these original data files that have been untouched, and they can remain that way and be put into your deliverable or your archiving. And then we have all these files that say -ADT afterwards. Again, we could have created the initial reports about data quality and the data viewer file at the same time. We decided not to do that and save it. And then we have the multi-view report. Just move this back out of the way, and we'll come down here and look at our report. So this report might not look like much. Again, like much of the reporting done in ADT, it's done in Excel. We'll start at the left. We got some basic file info just to know what software version you're using, kind of like that. We do relist our data quality metric we touched on during the scan check module. Tells you what you decided to list by in case you pass this report to somebody else they can understand. And then we go right into quick stats, so you kind of get the big picture. So total number of welds processed was 50. If you want to know which one had the longest indication, we can tell right away. That's this data file, which indication and how long it was in inch and metric, almost a ½ inch. Which one was the tallest or through wall height extent, that's listed here in a similar fashion. And which one is the widest, so in the probe in and out from the weld or the index offset, which one had the widest footprint as far as indications found. We go over to the right hand side and we basically have all of our files reviewed, listed out by total hot list size. So this wasn't the order they were processed. We've ordered them by choice by the number of indications. So like I said before, when you have 50 files, you don't know. The last file could have 30 indications in it. You could have a bunch of bad data quality. So if I want to do this, I probably would look down on this data quality first, realize I don't have any real severe issues. I have one that might have just a little bit of loss of couplet ADT found, but no of those 2 adjacent data dropouts or 2 per inch. Just saves you a lot of time, so you don't get to file 50 and figure out, oh, I got to go rescan that, but you've already left for the day and you were doing analysis in your hotel room or back at your NDT shop. I can also get a good threshold, so ADT didn't find a lot of indications. This is going to be my most probably lengthy file. It's got 6 total indications found by ADT. If I was doing this to ASME, I know 2 might be rejectable. If I was doing it to AWS, I know 6 might be rejectable. And then we go down, we can kind of see that for every one. We don't have a lot of concern here about a bunch of indications having to spend a lot of time, and then everything after this point is zeros, that ADT didn't find any indications. So I can tell if I grab these, a big large number of them is going to be pretty easy to go through. So again, based on this, I can kind of give a good idea based on my experience about the number of welds. Now I know there's no data quality issues to deal with, and there's also a pretty small number of total indications.